Hello, this is mathjazz from Almost Cool, and this is another episode of Variant Limits. So, let's see. Where we left off before, we started doing computations-ish, with our limits. Oh yeah, and then we found out that story-wise, we were reading up about some people who were building ships to get off the planet before the cataclysm hit, and then people fighting over who got to go on the ships because there weren't enough ships.
A battery can be connected to a node instead of linking it to the power matrix, providing alternative means of operation.
Which is a crass way of saying that finding batteries could be extremely helpful, under the circumstances.
So, is this a battery, or this where I put a battery? And I also don't know how it was a crass way of saying anything.
Emitters can hit the nodes we need.
Confirmed. A new limiter must be programmed that combines two functions for a new operator. This will allow access to a new addition, multiplication, or division functionality.
We've made it this far, Iqua. You can do this. Just work through the problem one step at a time.
Okay, so we have a 3 and a 1, and we can't add 3 and 1 to get 3, but we can multiply them, so guess we, not really sure how this works. Let's see. Oops. Okay. So, I want f times g, and I'm going to use the values. Yep. Can I drag those somewhere? Place them here. Oh. At each input value, predict the limit from the left of the combination and the right and the value. Okay. So, I guess this means that this would be continuous from the right and f is continuous from the right and left, g is continuous from the right and left. Or maybe just f times g is continuous from the right and left. Ah! Okay. Wait. What did that do? Okay, so by doing this limit thing, it allows me to switch what operation is between f and g, so I can switch between addition. So, g is 1, f is 3, so my sum is at 4. I can switch it to multiplication. G is 1, f is 3. Multiplying them gives me 3. Okay.
The Eos's docks. A testament to Manthan efficiency.
The largest of the coastal ports, Eosus serves as a nexus for exchange of goods from all major cities.
The Archivarium lies ahead. A kind of monument to our technical achievements.
Confirmed. In addition, the Archivarium contains the master node for the Citadel's division of the power matrix.
And if we activate the master node, it will redistribute the power flow. We can restore power to the entire island. Come, There is no time to lose.
I can't tell if that's a beam or a graphical glitch. But there's a line that's going from the bottom of that tower out to the right into the middle of the ocean. Maybe, is it visible on recording? Yes, it is visible on the record screen, so it should be something that you guys can see me talk about too. I guess, does that mean that that tower is the Archivarium? Of course, Archivarium for archive. Let's see. We want to hit 5, and we have Ive Ever Won is 5, so we're already lighting this up. But we could light that up over there. So, let's see. It's probably another one we're going to patch, but let's just look through this to see if we can come up with a way not to patch it. It looks like if we did F over G here, that should hit our target. That's -1 divided by -1 is 1. That is not hitting the target. Why is it not hitting the target over there? That is strange. This one here should hit a half, because it's the value... Oh, well, we'd have to take the limit from the right. That'll open that door for us. Let's go through the door and see what lies behind it. Oh, we got a battery. Or we can place a battery? Huh. I guess we can place a battery there. So, let's swap this over to the other value. Let's patch the limiter. Let's see. So, F times G would be... this would be continuous from the right, but not the left. I think I get this now. So, F times G would be continuous from the right, because G is from the left. Continuous from the left, because G is continuous from the left, and F is also continuous from the left. But, since G is not continuous from the right, we have to handle that case individually. So, as X is going to 3, F goes to 2, and G goes to 4. So, from the right, F times G goes to 2 times 4, which is 8. But from the left, we go to F goes to 2, G goes to something a little smaller than 2, so this goes to something a little less than 4. So from the right, the product of F and G goes to something a little less than 4, but from the left, the product of F and G goes to exactly 8. So it is continuous from the left. Its value is going to... Actually, its value will not be... Yeah, its value is going to be... Because the value here is 2, the value here is slightly less than 2. So what it goes towards from the left is equal to what it equals. That sounds weird. The limit from the left is equal to the value of the function. So the limit of the product is equal to the value of the product. But the limit from the right is not equal to either the limit from the left or the value. So this should be correct for this line. And then here, let's do the same thing. So the value is -2. The value here is like -1, -2/3. So this is the product of these values is going to be like -4/3. From the left, I go towards 2 on F, and I go towards -2/3 on G. So the limit from the left of the product is equal to the value of the product. And coming from the right, F goes toward 2, G goes toward F goes toward -2, G goes toward negative 2/3. So the limit from the right is equal to the limit from the left is equal to the value. So this one here will be continuous. And now if I hit patch limiter, oh, it didn't like that. Why didn't it like that? So the value should be 2 times something slightly less than 2. The limit from the left is 2 times something slightly less than 2. So this should be continuous from... Oh, okay, so do I need to do this? The limit from the right is about, well, is equal to 8. The limit from the left is slightly less than 4. And so, is this what we want? Yes! Okay, so notice how this is our limit from the left of our product. This is the limit of the from the right of the product, and the value of the product is down here, which it won't let me drag this dot off to show you, but here, on the other hand, since we are continuous, we have the limit from the left, the limit from the right, and the value all equaling the same thing. Okay, and that's why it lets you get, well, from earlier you saw we were able to get 3 different orbs, because at our worst case scenario is we have a limit from the left, and a limit from the right, and a value, and all 3 of them are different from each other. So we need 3 orbs, one for the value, one for the limit, one for the other limit. Okay, so we've patched that successfully, and now we want to aim at 1, which I guess we can switch to the product now. So this makes it quite a bit easier, because now we're only controlling an input variable and 1 function instead of 2. Like, we have to look at 2 different functions and divide them here, but we just have to multiply them here. So that's nice. And now we will teleport. Can I jump that? No, of course I can't, because I can't jump. And this would be a neat little platformer if I could platform, if I could jump. Okay. Is there a way to, like, convince it to give me a second one? Nope. Oh, I'm not able to jump back? There we go. And it would be terrifying to, oh, now I have to switch the portal, or the beam back. So... Can I do it just with... Yeah, I can probably do this with just... But... that equals a half, it says so. That should totally hit the target. It doesn't want me to do that though, I guess. Ah, because I'm doing the limit from the right, and what I want is the limit from the left if I'm going to do that. Sorry, no. Yeah, this should work, because I have an output of a half, that should hit the target. It doesn't matter if I'm doing the value or the limit or whatever. Okay, so that's a bug. What did I need? I need it over here. Oh, and I forgot what I was on. That seems to work though. Okay. Great. Now we put the battery there. And we can go that way, or we can read the book. The storms are getting worse. It's as if the anger between my sister and I manifests in the magnetosphere of our very planet. It's ludicrous. Yes, it is ludicrous. I know, but the electrons do not care how we feel, but the poetry of this metaphor haunts me. Sometimes I think if I could make peace with Vatra, but how can I apologize for something I didn't do? What's worse, I now suspect her enhancements to the power matrix might be causing the geomagnetic induction at the heart of the storms, yet she will not listen to me, and I know too little of her mechanical designs to try and intervene. Oh, so it's, the dwarves delved too deep type thing.
Excellent, Iqua.
Oh. Is that supposed to go on longer? I see, every once in a while, I just feel like I accidentally cut off the dialogue or the voice, and I might be missing key information, you know, plot stuff. Should be able to hop down on that boat. Might not be able to climb back up from it, but I should be able to hop down. I know that going up that stairway is what's going to advance the plot, but I just want to see what else is here. Okay. I think that the trees and
That
bushes
looks like a cargo
in the
transport
game look
pad.
pretty cool.
Confirmed, although currently disconnected from the power matrix and inoperative.
That could take us straight to the Archivarium if we can find a way to restore power.
A minimum of 3 industrial batteries must be connected to facilitate this operation.
Well, we're in the right place to find batteries large enough to power the transporter.
How
Come
do
on,
we know
let's
that?
start searching.
How do we know that we're in the right place to find batteries? Like, this place looks completely uninhabited. Who's to say that these people didn't take all of their batteries with them when they left? Okay, so think that what I need to do is get batteries to this. Cool. Okay, so this is the first open door I find, so I'm gonna go through it. And let's see.
It doesn't look as if the magnetic storms have been quite as disruptive.
Incorrect. Widespread system disruptions detected.
Well, thanks for crushing that brief ray of hope.
Okay, so where should I go first? Let's hit. Let's see. I should be able to hit. F times G. So I get a -2 down here. Let's do the patch. See if we can get something from this. Okay, so here we have F is continuous at the first spot, but G is continuous only from the right and discontinuous from the left. So, and looking at this, it looks like the limit from the left is going to be bigger than the limit from the right. So we will have 2 spheres. The limit from the left and continuous from the right represents this here. I don't really have to do any numbers. Just graphically you can kind of read that information off. So here, it's the opposite. I have F is continuous. Oh, F is the white one and green is the G. Oh, I said it backwards earlier. The green was continuous, the white was discontinuous at the first one. Now it's the white's continuous, the green is discontinuous. And notice that if I add the white to the green here, it's going to be a bigger number then adding the white to the green on the left side of this critical line here. So I'm going to need 2 orbs. I'm going to have the limit. The limit from the left here is going to be lower than the limit from the right, which is going to equal the value, because this value plus this value is equal to the limit of this plus the limit of this. But the limit of this plus the limit of this is smaller than both of those. So this is how we set up my orbs here. Here I have 2 continuous functions, and the sum of continuous functions is continuous, so I only need 1 orb here, and I mark it as continuous. Not just continuous from the right or continuous from the left, but fully continuous. And now I hit patch limiter, and my orbs go into the right place, and oh, these orbs are really close to each other, but it works. And then we go back, and now we'll swap, because this is way easier to control. So let's see, we need a 6. Ooh, there are no 6s on this, are there? Highest it goes is 5. Well, we won't go to 6 next, we'll go to 2 next. So 2 is here. We'll take the limit from the right. Notice that as I come up from the right, I hit 2. So we'll go here first. I guess we'll go to -2 next, and then we'll figure out what to do about 6 afterward. So here we go. So where's my teleporter? Here's my teleporter. Okay, now that I'm over here, what do I do? Ooh. I have to hit that with a beam from somewhere. Battery. No, that's a place to place a battery, not a place to use a battery. So it looks like we came to the wrong place first, because there are no power sources here for us to use. So we'll go back, and we will choose another place to go. So if we choose this spot, we'll hit the other target over here. That'll let us hopefully find a battery. I wish I could see. Looks like there's nothing there, though. Yes. Why can't I jump off of that? Okay, so now we go back to where we were and place the battery. That was here.
Excellent work.
Maybe I should have placed it here. I wonder if I can place it there. So that answers a question that's important. You are able to reclaim batteries that you have placed. So, let's see. I don't know exactly what happened, but something happened. Okay, so now we need to figure out a way to get a 6. So, I think that we want to do this here as a limit from the left, because now we have a -2 and a -3 that multiply to get 6. Okay, so now we're over here. And there's a pad, and it probably goes somewhere. Okay.
I know we have more pressing concerns, but is there no way we could mitigate the effects of the new cataclysm? Must it end with the sterilization of the planet?
According to projections, peak coronal ejections would not only incinerate all animal and plant life, but also render soil microflora inert.
There could be no coming back from that. But at least, if we disrupt the tether, we'll buy ourselves some more time.
Oh, this is cheap. Look at that. 2.1 to 1? That totally looks like a 2 here. Doesn't it? That looks like a 2. That looks like a 1. 2 over 1 gives us 2, which should hit that spot there. Oh well. How about... That's, not gonna work. We have a 5 and something bigger than 2. Yeah, it looks like none of those work for us. Oh wait, how about this one? We choose the limit from the right, and we hit the 1, so we can go somewhere. We'll patch it later. Go up here. We need a battery. Okay. I kind of want to go back and grab that battery we left behind. I don't know if it'll let us do that. But, okay, so this one won't exist because G, the green one, doesn't exist. This limit here will have continuity from the left, but not from the right, and the continuity, the value and the limit from the left will be bigger than the limit from the right, so we'll need 2 of these, and it'll look like this. And here we have continuity from the left, but not from the right, and the limit from the right will be bigger than the, the limit from the right will be bigger than the value and the limit from the left. We put those in, they work, and now we switch to here. We want to get a 2, so that'll work. Here, can we grab battery? No, we can place a battery. So let's go to the other spot. Let's see. We need a -2. So I think this is what we want. Over here. And can I go through that? No, I can't. Looks like we need to go back for that battery somehow. Is this where we get it? Oh, you know, I didn't notice this staircase before. Let's try going up this staircase. Where does this go? With Father gone, it becomes clear that our people are not as united as I once believed. The feud between my sister and I is mirrored in the conflicts between our cities, and the as-yet unanswered question of who now leads the Citadel. I still blame Ava for my father's death, but I cannot deny that we are both responsible for this political fiasco. The solar flares worsen as the new cataclysm draws ever nearer, and now we have a new problem. As magnetic storms have struck every city, I begin to worry that my own modifications to the power matrix might have had something to do with this heightened geomagnetic activity. Oh, how did I get up here? There we go. Okay, let's go back and figure out how to grab that battery that we left behind. I saw this one before. Okay, so we want to hit a target of 8, and we have here this. So let's see. This is addition, and that's not going to reach 8 ever, because the highest one of our functions ever gets is 4, and the other one is less than that. So if you have two numbers that add together, and one of them is half of your target, and the other one is less than the first, then you're going to be less than your target. So we have to do a patch here. So this is the only spot of interest. From here, let's see. So our value for our function is going to be 1 times 4 is 4. And then the limit from the right is going to be 4 times 2. I'm sorry, I said right, I meant left. 4 times 2 is 8. The limit from the right is going to be 1 times 1.5 is 1.5. So we're going to need all 3 orbs here. And let's see. So I said the limit from the left is 8. The value is 4. And the limit from the right is 1.5. So this is the order they go in. I wonder, does it matter what order I do these? I'm gonna plug these in wrong just to make sure that I have this idea right. So I said the value was in the middle, and that the limit from the left was the biggest number, and the limit from the right was the smallest of the 3 numbers. So I'm gonna try hitting patch limiter and see if it throws an error, because it should really. Like, part of this should be figuring out which of these values is bigger than the other values. So I'm gonna hit yes. It does throw an error. Let's try doing it the right way. And if I hit patch, yes. Just as I said, the limit from the left is the biggest, the value is in the middle, the limit from the right is the smallest. And the order does matter when you're solving this, which is what I would expect, what I would hope. Okay. So, now that we have this patched, we want to find where it equals 8, which is here. Which is great. Okay, so now what? I guess let's follow that, because we don't know where it went. Or where it goes. Ah! Yes, I know where this is. This allows us to pick up our battery and take it with us. I'm so happy. I wonder if we can hold multiple batteries at the same time. Because, like, I don't see where Equa is carrying any of the batteries, so they must not be very big. I guess they fit in that backpack. And if they fit in that backpack, then I should be able to carry lots of them. Because that backpack is... well, it's a small little backpack. But... okay, so now I want to go... actually, I want to go right back where I was, because I need to go to the other teleport pad over here. Should we ever go to the spot that was labeled 6? I don't remember. Anyway, let us... we want to shoot for 2, I think. Oh, it froze. There we go. So we want to hit 2, which is going to be over here. That one? No. There we go. And now we'll try placing the battery here and seeing what happens. Can't go through that door. And... oh, really? There we go. Well, it looks like we get another battery, which is great. We don't get one from there, though. Oops. I think that we're going to have to wrap this up here, and we will see what's in the top of this building when we come back next time. So, hope you're having a great time learning calculus, and I hope that you're enjoying watching this Let's Play. So, see you next time. Bye!